Hi, my name is Rich Confuso. The goal of today's demonstration is to demonstrate Cisco Wide Area Application Services. We're going to start by explaining a few of the terms and walking through the architecture that I'll be using for the demonstration. What you see here is basically the lab architecture that we'll be logging into to walk through the demo. We have two locations, a core location and an edge location simulating the main data center and the remote office. And then we have a server set up in the main data center and a client at the remote office. And in the middle here you'll see we have a WAN emulation device called a Network Nightmare, which will function as the default gateway. A few terms that you should be familiar with before we get started. Each one of these Cisco WAAS boxes I'll refer to as a WAA, Wide Area Application Engine. The deployment model used here is something called the inline deployment, which means it sits between the router at both the core location and the core VLAN, and the router at the edge location and the edge VLAN. So what we'll be doing is we'll be logging into both the core and the edge. We'll also be logging directly into the WAAS devices to shut the interfaces, shut down the interfaces, and start the interfaces, so you can see what performance looks like with both accelerated and unaccelerated traffic. I'll also be logging you into the Network Nightmare device to change latency, and we'll be doing some pings to prove that the latency is actually there, and the round trip time is actually correct. So from here, we'll probably pop back to this picture later in the demonstration, but from here I'm going to begin logging into the hosts. So the server box that we're working with has an IP address of 192.168.100.51 with a default gateway of 100.251. We'll actually be adding that default gateway live so you can see the route statement get entered. And then the edge device we'll be working with is 192.168.200.251, and 200.51 with a default gateway of 251. So now I'm going to log into the remote host. As soon as I find my right, here we go. So I'm going to log into the server first. So I'm logging into 100.51. I'm opening a remote desktop connection to it. Okay. So 100.51 is now started. The remote desktop session has been started, and I'm going to also open up the remote desktop session to the edge device, which is 200.51. Okay, so now I have both the core and the edge sessions open. And the first thing I'm going to do is I'm going to open a command prompt on the core, and I'm going to list the routes. And as you can see on this box, 100.51, we do not have a route set specifically to the 192.168.200 network. So right now everything is routing through the default gateway of 100.1, which is a standard LAN router, no WAN emulation. So what I'm going to do is I'm going to start a little tool called Ping Plotter, and we're going to ping 200.51. So you can see here that we're pinging, and there's multiple samples being taken, and basically we have 0 milliseconds of latency because this is simulating a local area network. So I'm going to stop this real quick, and I'm going to pop over to the edge location and basically perform the same task. So when I do a route print, you'll see here on the 200 side that I have no specific route to the 100 network. So my default gateway is 200.1. So again, if I open Ping Plotter and I ping the other direction, you see I'm getting 4 milliseconds of latency, and my guess is that will decrease over time. You can see now it's dropping. The average is now 2 milliseconds. reduce this to 1 second so we can move faster. So you can see, anywhere between 2 and 4 milliseconds, 0 and 4 milliseconds of latency. So land speed, pretty much. I'm going to stop this, and I'm going to pop back over to the core device, and now we're going to add a route to the 100 network. So I'm going to route add. Oh, sorry. So basically what I'm telling it is to add a route to the 100 network with the default gateway of 100.251. And we're going to enter that in, and then I'll run a route print again. And you'll see here now that I have to the 100 network. Oop, sorry, my bad. To delete that route. I'm going to route add 192.168.200.0. I'm adding a route to the 200 network because I'm on the 100 network already. And the router, the default route will be 100.251. That's the default gateway. And we'll do a route print again. And you will see here that on the 192.168.200.0 for the network destination, our default route is now 192.168.100.251. So what we'll do here is we will resume this test, and you will see that I currently have 40 milliseconds of latency here, and we'll actually go ahead and tweak that that latency. And part of the reason why the round trip latency is because a lot of this I haven't changed the default gateway. So this should actually go to 80 milliseconds of latency when I change the default gateway on the other side. So I'm going to stop this real quick, and we're going to flip over to the edge, and we're going to do the same thing here. We're going to route add 192.168, and here we're going to the 100 network from the 200 network. Yes, 255, 255. And we'll do a route print, and you will see now the route to the 192.168.100.0 network is 192.168.200.251. And again, we'll come over here and we will rerun the ping, and now you'll see there's 80 milliseconds of round trip latency, and that's because the routes are both going through the WAN on both sides. And we'll run the same thing here, and you'll see that there's 80 milliseconds of latency here. So now both of these machines are running through the WAN emulator with 80 milliseconds of latency. Total bandwidth is a T1, and I'll show that to you in just 1 second. So we're just going to stop this. We're going to close this. We'll stop it on the edge as well. Close this. I'm going to exit this command window just to clean up the desktop. Exit here. And I'm just going to open this up just to, okay. Now we will log into the Network Nightmare. So here now I'm logging in, and let's see. go through the serial connection. So serial in, and you will see here that basically this is the emulator. So I'm running at a T1 speed at 80 milliseconds latency and 0.01% packet loss, just to show that this is actually in line and we are getting the emulation. I'm going to change this to 160 milliseconds of latency. Let's say OK. Now it's been changed. Now I'm going to come back to the ping plotter, and I'm going to run. I'm going to rerun the ping again, and you'll see now we have 160 milliseconds of round trip latency, which is exactly what we want. So we'll go ahead and change this back to 80 milliseconds, and you should see in the background here it changed back to 80 milliseconds. And there it goes back to 80 milliseconds. Okay, so now we're going to exit Network Nightmare. Okay, so we're closing the session. I'm going to close the ping, and we're going to start running some tests. So the first thing I'm going to do is log into the WAAS box. So I'm going to log in. We're going to do most of our work from the edge. So we'll come over here to the edge location. And the first thing I'm going to do is open a tool called NCFTP. And I'm going to open a predefined FTP site I have called Core. And we'll just do a dir. And you'll see here that there's 4 files. These are basically PDF PowerPoint documents, and we're going to transfer these across a T1 at native speed. But what I'm going to do is I'm going to shut off the inline WAAS card, so basically it becomes a pass-through and there's no acceleration. And then we'll transfer these documents, and then we'll transfer them with WAAS and let you see the effects. So right now I'm going to log into the WAAS Edge. Okay, so I'm now logged into the Edge, and I'm going to go into configuration mode here. I'm going to select the interface, inline group 1/0. Okay. And I'm going to do a shut. So this is basically shutting off the interface. So now the interface has been shut off. So if we refer back to our document, currently I'm logged into our architecture. I'm logged into this box, and what I've just done is shut the interface here. So this essentially has become a pass-through. We're not accelerating traffic. So what we'll do is from this side, we'll just run the ping again, just to prove that we're going through the WAN emulator. I believe we're going to have to give it a second. There we go. It takes a second. There's a little network blip when you shut that interface. So you can see we're still getting 80 milliseconds of latency. That's exactly what we want. So I'm going to close this, and we are going to quit this and reestablish our FTP session. Okay, let's just create a directory on here called temp. Let's go to FTP, okay. So I'm just changing the local directory to FTP, and we'll just make sure we do have it changed. And then what we're going to do, we'll do an mget but I just want to make sure we force an overwrite. Okay, so now I'm going to do a dir, and those files are there, so I'm going to do an mget-f, which forces asterisk. And basically we're going to start fetching these files. So you can see here, this will track, so we're getting 160 kilobytes per second, which is roughly T1 speed, so this will take a few minutes to finish. While this is running, we can come over here to the core, or really anywhere. Just happen to be easier to get to the web page from here, and we can log into the central manager of the WAAS devices. And you can see that basically we have 3 devices, 1 core and 1 edge device, and a central manager. And we can start to see that we're seeing the FTP traffic now. 3% of our traffic is FTP traffic, and as we run more of these transfers, we'll see more of that. Right now, remember, we have it shut, the interface shut, so we're not getting any of this. So we'll kind of leave this open so we can track it from the GUI. And the transfers are almost done, pretty consistent speeds. Okay, so we're done. So what we're going to do is we're going to quit, because we want to reestablish that connection. And I'm going to open the interface back up. So I'm going to do a no shut. And now the interface is back online. And we're going to exit again. And we're going to do a clear cache query. And this is just making sure that we clear the WAAS cache, so we're not getting a cache effect when we do the initial transfer. So we're going to run really 2 transfers here. The first transfer is going to be just transferring the data with WAN acceleration, because obviously it's not cached yet. And then the second transfer, third, fourth transfer will be accelerated transfers. So I'm just going to open the ping plotter back up again and just run another trace. And you can see still 80 milliseconds of latency. And we're going to close this. Once we run a couple transfers, I'll increase the latency and we'll run another transfer, and you can see what it's like cached. So next step is to open my FTP client again, open core. I'm going to again lcd to c:\FTP. That's my local directory, and then we'll do an lpwd and just verify that, and it is. Okay, and then I'm going to do an mget-f again, asterisk, and we'll get all these files. And now we are transferring these files. This is accelerated, but not cached. Come over here and we'll just do an update. We should see that we're it'll take a little while for this to update because I just cleared the cache, so it doesn't have any of those statistics. But you can see we're getting increased performance over what we were getting when we ran the native transfers. Roughly about 40% increase. so now we're going to run the same transfers again, and we should begin to see a cache effect taking place. And sometimes it takes a couple transfers. And there we go. So this is now we're seeing the caching effect. Run it again. Definitely seeing a huge impact once the data becomes cached. So what I'm going to do is I'm actually going to go back to the network nightmare. Just update this, see if we picked up any of the traffic. Not yet. And we're going to log into the network nightmare, and we will increase the latency to 300 milliseconds. And we'll come back here. And we will ping this guy again, and you'll see that now we're getting 300 milliseconds of latency. So we'll close this, and I'll leave that connection established. And I'm going to come back over here. Let's just run one. This is a transfer with 300 milliseconds of latency. And you can see it's definitely taking a lot longer to make the initial connection. But once we make that initial connection, we're still getting that cache benefit. Run it again. This is again latency playing a part in the connection speed. And just to give you an idea, I'm going to come over here, I'm going to shut down the interface. We will, so here are the numbers for, this was accelerated on the first time, no cache effect, all cached, and then basically once we had switched over to 300 milliseconds of latency, roughly the same speeds, even with 300 milliseconds of latency. So let's go back over here and shut the interface again. And let's run a transfer with the interface shut down, just to give you an idea of the difference in speed. You can definitely see the connections taking significantly longer. This may be because we may need to establish the entire FTP session. So I'm just going to break this, and we will just establish the new session. Oops. Let's just check connectivity here by running a ping again. Yeah, 300 milliseconds of latency. Opening up to the core again. LCD, okay, so we're back there again. CDIR. And we will just get one file because it's going to take a little while, so we'll just get the first one. So now you can see the effects with 300 milliseconds of latency and no acceleration. We're down from about 160 kilobytes per second to 27 kilobytes a second. So you can get an idea of the effects that latency has on transfer speed. Still a T1, but with 300 milliseconds of latency. Dramatic reduction in performance. After this, I will re-enable acceleration, and we'll run the same test again. Let's flip back over to the core and just see if we have any updates here. Yeah, so you can see now we're actually getting, you can see my connection actually. You can actually see my remote desktop connection, which is my laptop actually connected to the remote site, the 200 site. You can actually see that RDP traffic being accelerated. There's definitely some SQL traffic, and that actually is coming from some of the applications that are running on these laptops, on these servers. This is just about completed. So that completed at about 37 kilobytes per second. So I'm going to quit this session. We'll restart that session. I'm going to do a no shut on the interface, which is basically going to restart that interface. I'm going to exit. I'm going to clear the DRE cache again, so we can do it with 300 milliseconds of latency. So now the cache is being cleared, so we'll be able to see the initial transfer speed, the effect of WAN acceleration on the initial transfer speed, and then the effect the caching will have on subsequent transfers. So I'm going to FTP back to that box. Opening connection to the core. Logging me in. CD back to FTP again. There, DIR, and I'm going to do a get again because it could take a little bit longer here on just the first file. So this is with acceleration but not cached, and you can see we're definitely getting significant performance increase over transfer speeds without WAN acceleration. So we're negating a lot of that latency penalty. Much faster. So now we're going to transfer this again, and this is a cache transfer. And sometimes it'll take a few times before it ramps up to full speed because it takes some time for the way to do some work. You can see we're getting about anywhere between 1.5 to 2 megabytes per second. So that's pretty much the demo. So from here, I'm just going to close out, and that'll conclude at least the first demo. Hopefully I'll be doing another one soon that will cover CIFS.